All right, so today we're really not doing anything new. We're just going to take all the things that we've learned so far in this chapter and combine them into certain types of problems. So these are a review of some rules. We'll come back to these when they apply to the problem. So this one asks you to do the square root of 49, x to the 6th. And remember, if you don't see an index, that's really a 2 here. So the square root of 49 we know is 7, and x squared, x to the 6th means you're going to take out as many groups of 2 as you can. So we've got x cubed. So the final answer is 7x to the 3rd. All right, next problem, we want to know what's the cube root of 64. So that's 4, so it's negative 4. And then we have x to the 12th. We're going to take out as many groups of 3 as we can. And the quick way to do this is to do 12 divided by 3, right, which is 4. So x to the 4th. All right, for problem number 3, we've got the cube root of 81. Now, the cube root of 81, that doesn't give us an integer. So we're going to have to figure out, is there a perfect cube that goes into 81? And a perfect cube that goes into 81 is 27. So this could be rewritten as the cube root of 27 and the cube root of 3. The cube root of 27 is 3. And then left over inside the radical is 3. And then we can take out 3 groups of x's with 1 left over, and 2 groups of y's with none left over. If you need to see it worked out, you can write out 10 x's, circle as many groups of 3's as you can. There's 3 outside and 1 left over on the inside, and then all your 6's. You got 2 groups of 3's and none left over. All right, moving on, we've got a cube root of a fraction. So either you could divide 8 over 125, or you can split it up as the cube root of 8 x to the 9th and the cube root of 125 y to the 15th. So can you do the cube root of 8? Well, try it on your calculator. You can look at your perfect cubes list. All right, so that gives us 2/5. So a 2 and a 5. And then if we do 9 divided by 3, we get x to the 3rd. You could write out 9 x's and group them, or you could write out 15 y's and group them, or you could do 15 divided by 3, and that gives you y to the 5th. So 2/5 doesn't reduce, and x's and y's are different bases, and then that's the answer to your problem. All right, so we did this the other day where we take a square root and a square root, and we can multiply them, and it becomes another square root. So you just multiply the insides. 10 times 10 is 100, and x to the 7th and x to the 5th, you will add those. So that's a reminder of our product rule, right? If you multiply with the same base, you add your exponents. So 7 plus 5 gives you x to the 12th. And then what is the square root of 100? Well, that's 10, and then 12 divided by 2 gives you x to the 6th. All right, so this is what we had yesterday. We can rewrite this as a cube root. Look at your denominator. That tells you your index. So cube root of 125 squared. It's much easier to take the cube root of 125. Well, actually, we just did that first, rather than to square it and then take the cube root. So we have 5 squared, and 5 squared we know is 25. Okay. So if they're going too fast for you, rewind the problems or watch them again. You can do that. Otherwise, we're going to move on to problem 7. So 64 to the 1/2. The 2 is my index, so it's the square root of 64 to the 1st. The square root of 64 is 8, and 8 to the 1st is just 8. All right, so some of these simplify really nicely. Other times you have a lot of stuff left over. All right, so this means that each thing inside the fraction is raised to the 3/4 power. So I'm going to convert these into radicals because I think it makes a little more sense to see it in this format. So I have a denominator of 4. It's the 4th root of 16 cubed and the 4th root of 81 cubed. So figure out what's the 4th root of 16. If you don't know it, use your calculator. All right, so that's going to give us 2 and 3. So it's 2 to the 3rd and 3 to the 3rd. Which we know 2 to the 3rd is 8, and 3 to the 3rd is 27. And that does not simplify, because you can't divide 8 and 27 by the same number. All right, so again, we're going to rewrite this as a cube root of 8 squared. So we've got 2 squared, and 2 squared is 4. If you don't remember how to convert, you can look at yesterday's notes. Okay. And then this is an example using the product rule. If you have the same base, you keep the base the same, but you just add the exponents. So if you notice, we're multiplying, and they have the same base of 5. So don't change the 5. All you're going to do is add 1/2 plus 1/2. Right? If you don't know how to add your fractions, 1/2 plus 1/2, that equals 1. So this is really 5 to the first, and 5 to the first is equal to 5. Okay, my 10s are my bases. Keep it as 10. Do not change anything. So 1/3 plus 5/3. 1/3 plus 5/3 gives me 2. So now my exponent is 10 to the second, and 10 to the second is 100. All right, in this one, we have 16 as my base, so keep that the same, and you're going to do 1/4 plus 1/4, which is going to give you 1/2. All right, you can verify that. If you get a decimal, you change it to a fraction, so that's 1/2. Now this didn't turn out to be a whole number, so let's convert this to radical form, just like we did over here. So we have the square root of 16 to the first. Square root of 16 is 4, and 4 to the first, anything to the first power is just that number, so you get 4. All right, last one like that. We have a base of 5. So we're going to add 3/4 plus 9/4, and that's going to give us 12/4, which is 3. So 5 to the third. And if you don't know what 5 to the third is, you can figure it out, and that gives you 125. All right, so this is a rule that we did on the first day also. You have a product raised to a power, so you distribute. You have 2 cubed and x to the 2/3 cubed, right, which means you're going to multiply. So we got 2 cubed, and if we multiply 2/3 times 3, that gives you 2. So we have x squared here. Right, as a reminder of this rule, if you don't remember that, if you have a power to a power, you multiply your exponents. All right, so how much is 2 cubed? That's 8, and this is 8x squared. And then our last problem, we're going to raise both of these terms, so 27 gets raised to the 1/3, and y to the 15th also gets raised to the 1/3. So we're just going to leave this as 27 to the 1/3 for right now. We're going to multiply our exponents just like we did over here. Right, x to the 2/3 cubed, that's why we multiplied, so same thing. That's going to give me 5, if you want to double check. That's 5. And 27 to the 1/3 means cube root of 27, so figure out what that is, and that is 3. What times itself 3 times will give you 27. Okay, so your final answer is 3y to the 5th.